Excuse me, 1, 2, 3. Welcome back, guys, to another video or stream on computer science. Today, we're going to be talking about database and um, everything that has to do with database, from the components to recent trends in the design of the database, the data warehouses, of the couple data marts, data lakes, business analytics, big data era, database marketing, Tableau, Power BI, the application, and that then we'll do a small review and then end it like that. Okay. So our learning objectives today is to define database, and a database management system. Explain logical database design and relational database model. Define the 5 components of database management system. Summarize 3 recent trends in database design and use. Um, Again, these are just a couple of things to keep in the back of your mind while going through this lesson for today. Describe the functions of data mart. Describe or compare and contrast data lakes and data warehouses. Describe the roles of business analytics and the decision making process. Examine the advantages and challenges of big data and predictive analytics for business. Explain database marketing and its business application. And then we're going to explain key features of Tableau and Power BI, because those two are the most popular business intelligence and visualizations platforms to date. And if you guys have been applying or trying to apply for data analytics, you guys probably have seen Tableau and Power BI listed as a very important software that these companies are using. All right. So again, there we go. Database. Okay. So we're gonna go through the text as quickly as possible. Second.
Databases. A database is a collection of related data that is stored in a central location or in multiple locations. You can think of it as being similar to a filing cabinet, in which data is organized and stored in drawers and file folders. As you can imagine, however, retrieving data from a database is much faster. Although a database can consist of only a single file, it is usually a group of files. A university database, for example, might have files for students, staff, faculty, and courses. In a database, a file is a group of related records, and a record is a group of related fields. This structure is called a data hierarchy, as shown in Exhibit 3.1. In the university database example, fields consist of social security number, student name, and address.
All right. So let's do a little review here. So this is the file, the whole file. This is what I was talking about in a hierarchy, which is, boom, boom, boom. And the field, which is all of this, or column, I guess you could say, that's what represents the field. And then the record is I would say the row, right? So let's just say the guy's name is John Brown, and he lives at this street right here, right? When you're looking at John Brown in the field section, you will find other people's names, right? You won't find um, the addresses column-wise, because um, it's more structured this way. Because believe me, I had it mixed before, where I had the field where it should be record and record should be field, and that database did not look good. Easy fix though, just change the two. Uh, Anyways, and then you probably see this over here. The number is probably their number. It could be associated with what they call it primary key. It could be like a customer ID that you're associated with because there could be more than one Mary Smith. Um, so everyone has their own unique primary key for these databases. All right.
All the fields storing information for Mary Smith, for instance, constitute a record, and all three records in Exhibit 3.1 make up the student file. In a database system, all files are integrated, meaning information can be linked. For example, you can retrieve the names of all students enrolled in Professor Thomas's MIS 480 course from the courses file or look up Professor Thomas's record to find out other courses he is teaching in a particular semester. A database is a critical component of information systems because any type of analysis that is done is based on data available in the database. To make using databases more efficient, a database management system, DBMS, is used. A DBMS is software for creating, storing, maintaining, and accessing database files. Its major components are discussed in the Components of a DBMS section later in this module. If you are familiar with Microsoft Office software, you know that you use Word to create a document and Excel to create a spreadsheet. You can also use Access to create and modify a database, although it does not have as many features as other DBMSs. For now, take a look at Exhibit 3.2, which shows how users, the DBMS, and the database interact. The user issues a request, and the DBMS searches the database and returns the information to the user. In the past,
Okay, let's have a look at this exhibit. This is the user, which is, maybe you. Let's just say you're a data analyst and you're trying to retrieve some information about a client or whatever. Let's say you want to look at John. Let's go John Brown. We're trying to find John Brown, where he lives, or let's say his customer ID. Right? We make that request for that information. If you guys remember from last time, information being the very end of the output. It goes through a DBMS, which was up here, data management system, which is a software that's created for um, databases, everything that's done with databasing. Uh, uh, After it asks that software, I think like maybe Power BI and the other one, I forgot the other one. Um, I guess you could say Microsoft Access as well, uh, but it's not as powerful as you may have read up here. The DBMS searches the database, right? The database is usually the storage of everybody's information, everybody's data. After it searches it, it finds it, it retrieves the information, it goes to the DBMS again, and then from the DBMS it goes to you, the user, the data analyst, or you, whoever is trying to get that data.
data was stored in a series of files that were called flat files because they were not arranged in a hierarchy, and there was no relationship among these files. The problem with this flat file organization was that the same data could be stored in more than one file, creating data redundancy. For example, in a customer database, a customer's name might be stored in more than one table. This duplication takes up unnecessary storage space and can make retrieving data inefficient. Updating a flat file system can be time-consuming and inefficient. Data might not be updated in all files consistently, resulting in conflicting reports generated from these files. In summary, a database has the following advantages over a flat file system. More information can be generated from the same data. Complex requests can be handled more easily. Data
I'm gonna skip on a little bit, get it a little bit faster over. Okay, the types of data and database. Okay, types of data. As you learned in Module 1, generate and understand the BI. See, there's internal data and there's external data. Everything that's stored inside would be internal, inside the company, would be, and then everything that is external data would be coming outside of the company, which is often stored in data warehouses. Let's see, the following examples are external data: competitors, customers, suppliers, distributed networks, economic indicators, government regulations, labor, population statistics, tax records, everything outside, and also in data warehouses. Okay. BI in law enforcement, business intelligence is the use of it is used in law enforcement as well as in the business world. So, it's not all about customers. It could also be for profiling. In Richmond, Virginia, data entered into a police department's information system includes crimes reports from the past 5 years, records of 9/11 calls, details about weather patterns, information about special events. The system generates BI reports and help pinpoint crime patterns and are useful for personnel deployment, among other things. The system has increased public safety, reduced 911 calls, and helped management make better use of Richmond 750's officers. So let's just say you're getting a caller, right? This caller is always complaining about their neighbors, maybe a noise complaint or something like that, and it's not that big of a deal to some of these officers. Maybe it's like, it's barely legal. They would more than likely just answer the phone and disregard it because that person that always calls has been profiled, and in that database management system that they have. Um, Perhaps they have it as like annoying annoying civilian always calls about noise complaints, right? That's the use of databases. All right, let's see. Let's continue reading on. Recently, the department refined its report separating violent crimes into robberies, rapes, and homicides to help them discover patterns for certain types of crime. For example, the department discovered Hispanic workers were often robbed on paydays. By entering workers' paydays into the systems and looking at the robbery patterns, law enforcement officers were able to identify days and locations on which the incidents were likely to occur. Moving additional officers into targeted areas on paydays has reduced the numbers of robberies. Isn't that great? Isn't information great, guys? Databases? Look, it's solving. Well, what it doesn't work against is, the improbables or the random the random strikers that you know, like there are some unsolved crimes here and there, and it's through pure randomness, pure RNG. Um, That's why a lot of these like serial killers are able to get away with like really crazy murders is because they have a strict system going on and also a little bit of randomness to it, right? Let's move on. Methods for accessing the files. Ooh, so there's sequential access file structure. Sequential file structure records in files are organized and processed in numerical or sequential order, typically the order in which they were entered. So if you enter person number one, that's would be person number one, let's say, and then there comes John Brown, and then there goes Mary or whatever. John Brown would be the second person, and then the next person would be the third person. That's sequential access file structure or sequential sequencing file or whatever. All right. Boom. records 1 through 10 must be read first, and it must go in that order. Random access file structure. I'm pretty sure you guys could guess what this means. The records can be accessed in any order, regardless of their physical location in storage media. The method of access is fast and very effective when a small number of records needs to be processed daily or weekly. If you have a lot of data, this would not be quick. Well, it's because it's only quick for a small number. All right, index sequential access method ISAM records can be accessed sequentially or randomly depending on the number being accessed. For a small number, random access is used, and for a large number, sequential access is used. This file structure is similar to book index that lists the page numbers where you can find a certain topic. Okay, let's go to the let's do a real life example of this with this book. Let's say you wanted to find something about computers, right? Or you wanted to find something about, let's say, the components of DBMS. We haven't gotten there yet, but you see how when you read this or you pull yourself out and read any of these things, and there it is, components of DBMS. Instead of flipping page by page by page until we get there, there is a glossary, I guess you could say. Very nice to have indexed sequential access method. Oh, I guess it's called an index. Hee hee. All right, next, logical database design. Before designing a database, you need to know the two-way information is viewed in database. The physical view involves how data is stored on and retrieved from storage media, such as hard disks or magnetic tapes. For each database, there is only one physical view of data. The logical view involves how information appears to users and how it can be organized and retrieved. There can be more than one logical view of data depending on the user. For example, marketing executives might want to see data organized by top selling products in a specific region. The finance officer might need to see the data organized by cost of raw materials for each product. So, if you guys understood that, let me know. The first step in database design is defining a data model. A data model determines how data is created, represented, organized, and maintained. It usually contains a structure, operations, and integrity rules. Data structure describes how data is organized, and the relationship among records describe methods, calculations, and so forth that can be performed on data, such as adapting and querying data. Integrity rules define the boundaries of database, such as maximum and minimum values allowed for a field, constraints, limits on what the blah 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 blah, all that stuff. Okay. So if we wanted to find John Brown again, we in the field we would define the boundary. Um, which has a maximum value of maybe his name, with being, what is it, John Brown. We would type in John Brown, and in the big database, we would find him immediately because everything else would be filtered out, except if anyone else has the name John Brown. All right. Okay. Many databases are often used. The most common, the relational model, is described in the next section, and you learn about the object-oriented model later. Okay. What is the object-oriented database, my bad. Oh, you could just skip ahead and learn about this right now if you wanted to. The relationship, relational model discussed previously in is designed to handle homogeneous data organized in a field and record format, including different types of data, such as multimedia files, can be difficult. However, in addition, a relational database has a simple structure. Relationships between tables are based on common value. The key, primary key, is what I said before. Representing more complex data relationship is sometimes not possible with a relational database. To address these problems, object-oriented databases were developed. Like object-oriented programming, the data model represents real-world entities with database objects. An object consists of attributes, characteristics describing an entity, and methods, operations, or calculations that can be performed on the object's data. For example, as shown in here, um, a real world car can be represented by an object in the vehicle class. Boom. The car one is vehicle class. Okay. Um, Objects in this class have attributes of the year, make, and model. There you go. The attributes of that in the year, make, and model. Um, you can then use methods to work with data in the vehicle object, which is somewhere right there, such as add vehicle, method to add a car to the database, uh, thinking of classes as categories or types of objects can be helpful. So we see this a lot of the times, not as simplified as this. It might be something a little more, I guess, user friendly. Um, Maybe I could pull up an example somewhere. It's called database object oriented database. Let's see if I can find a good image for you guys. If not, we're just gonna move on. Yep, we're just gonna move on. Cause it ain't that serious. To address these problems, I'll read one of those. Grouping objects along with their attributes methods into a class is called encapsulation, which essentially means grouping related items into a single unit. Encapsulation assists in handling of more complex types of data, such as images and graphs. Object-oriented database can also use inheritance, right? Which means new objects can be created faster and more easily by entering new data in attributes. For example, you can add BMW as a vehicle object by having it inherit attributes and methods of the vehicle class. You do not have to redefine the object, in other words, specifying all of its attributes, methods, every time you want to add a new BMW. This data model expands on the relational model by supporting more complex data management. So, modeling real world problems is easier. In addition, object oriented database can handle storing and manipulating all types of multimedia as well as numbers and characters. Being able to handle many file types is useful in many fields. In the medical field, for example, doctors need to access X-ray image and graphs of vital signs in addition to patient history consisting of text and numbers. So, meaning if you still don't get it, it's just saying that there is a much more specific application to for databases because you don't want to be too general in in database, because let's just say Microsoft Access, it'll store information about maybe a client or something, but you don't want to use the this one right here, the a database that doctors need to see images and graphics of a vital. This thing is more object oriented, hence the name, object oriented database. It's more catered towards doctors. And I think that's all you need to know about object oriented database. I probably could have made that a little bit easier for you guys. All right. Let's see here. In hierarch, if you guys could say that in the chat, let me know. All right. In hierarchical, you're gonna have to make her say this actually. Never mind. Anyways, hierarchical model is shown in Exhibit 3.3. Relationship among records form a tree-like structure, except if you notice the tree is upside down. Records are called nodes, and relationships among records are called branches. The node at the top is called the root, and the other called is child. The other node is called child and has a parent. Nodes with the same parent are called twins or siblings. So these are siblings to this parent, right? These are also siblings to this parent. And this is also called the root. The root node is a supplier which provides 3 product lines. Boom, boom, boom. Each considered a sibling of the other 2. They're all siblings. And then each product line has categories of products, and each category has specific products. Boom, specific products, and then maybe like raw materials or something to make that product, possibly. All right, the network model is similar to the hierarchical model. Hierarchical. Hierarchical. I don't know how to say that. But records are organized differently as shown in 3.4. The example links this example links an invoice number, customer number, and method of payment. For example, the invoice 111 belongs to customer 2000 who paid with cash. Unlike the hierarchical model, each record in the network can have multiple parent and child records, you see? So, boom, there's multiple um, cache things going on here, right here, right? It's not cut and dry like up here. All right, I hope you guys understood that. Because we're going on to the next thing, the relational model. Uses two-dimensional tables. Maybe I should start highlighting these things so that you can see the definition. There we go. Boom. Uses a two-dimensional table of rows and columns of data. Rows are records called tuples, and columns are fields also referred to as attributes. To begin designing a my bad. Let me check if Anyone saying anything in the chat? My bad. I totally did not have chat pulled up. So if you guys say anything, I do apologize. Pull it up real quick. Uh, Shoot. Okay, never mind. I'm just wasting time here. I don't want to go back and edit. So I'll just do this all in one take. If you guys say anything in the chat, sorry I can't read it this time around. I will get back to it after the stream. Um, for example, a student has, okay, to begin designing a relational database, you must define the logical structure by defining each table and the fields in it. For example, a student table has fields for student ID, student first name, and student last name, and so forth. The collection of these definitions is stored in the data dictionary. The data dictionary can also store other definitions, such as data types for fields, data values for fields, and validation rules for data in each field. As described in the following: field name, student name, admission date, age, and major, uh, the character, text, date, number, default value entered if none is available. For example, if no major is declared, the value is undecided. Validation rule, um, a rule determining whether a value is valid. For example, a student's age cannot be a negative number. Right. In relational database, every record must be uniquely identified by a primary key, which is like everyone's, like your student ID, right, is most likely a primary key. You're not defined by your name in the data. You're defined by maybe a big number, like if you go into the UHD, which where I'm going currently, our um, our student ID might start with like 133, 134, 135, maybe 14. Those numbers are up there in the was it hundreds of thousands, uh, and so they're going by um, those numbers, all right? Let's see, student ID numbers, social security numbers, account numbers, invoice numbers, they are all examples of primary keys. So they will be able to search up your invoice or your social security number. They're going to look up you because of these primary key numbers, right? They won't be looking for every, let's say, John Brown in the world. There's probably millions of John Browns. They would rather use the social security numbers because the social security number for John Brown is limited to one person. To establish relationship among tables so data can be linked and retrieved more efficiently, a primary key for one table can appear in other tables. In this case, it's called a foreign key. For example, a student ID is the primary key for the student table, and the codes for a student's major, such as marketing, MIS, finance, is the primary key for the majors table. Each student can have one major, and a number of students can be enrolled in each major. The primary key of the major table is a foreign key in the students table. That's a lot to digest. I wish they had a good a good image. It's probably a slide somewhere. I'm not gonna pull it up though. Next time though, I'll have it more structured. I have to pull up the slides. But for now, deal with it. To improve database efficiency, a process called normalization is used, which eliminates redundant data. All right. Improves database efficiency by eliminating redundant data and ensuring that only data related data is stored in the table. So let's just say you duplicated a couple information or data rows, right? Normalization would delete the duplicate. Normalization can go through several stages, from the first normal form 1NF to the fifth normal form 5NF. Typically, however, only 1NF through 3NF are used. For example, the following are performed in 1NF stage. Eliminate duplicated fields from the same table. Create separate tables for each group of related data. Identify each record with a unique field, the primary key. Oh, cool. Does it show you? I guess it does show you. Okay, cool. Select operation searches data in the table, retrieves records based on certain criteria, also called conditions. Table 3.1 shows data stored in a student table using the select MIS blah 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 3.2. Okay, let's see what we got here. So, whenever we see this right here, let's just say Juan. Juan's major is MIS, and also Muhammad is in MIS, right? Um, and that's not a duplication. So there's nothing wrong here. It's just um, Muhammad is taking MIS, and then Juan is taking MIS. Uh, let's just say an example of um, using the what is it, the foreign key. We're going if we filter out everything and kept MIS, right? Results for a select operation is what they will call it. Um, they picked obviously MIS right down here, and because they clicked on, like, if there's a filter button, there's usually a filter button around there when you use a DBMS, uh, database management system, and they filter everything else out, right? Like an example of why they would do this is maybe you want to create a group of kids that are in the MIS major and you want to send out a newsletter to them, maybe promote something that's related to MIS, right? So you would filter everybody out and then maybe with the student ID, or there's probably also like a lot more to the database, like a the student's um, email, or the not the actual email, but the student's student email, and then they could send out newsletters and all of that promotion towards MIS major students instead of the whole shebang, right? And going back all the way back to duplication and normalization, um, maybe they actually have it. No, they don't. Like they don't. Duplication would just be like, let's just say, um, Sue. There was the Sue, and then there's also another one down here, and it says like 222. Sue, she's a CS. She is a CS. Age 21, 36. Like everything is the same. That would be duplication. In that case, we would definitely delete, especially if it holds a primary key. However, the database management system most likely would never have a duplication error. Yes, invoice. This is what invoices look like. Obviously, it's a lot bigger. If you work in sales, you definitely see this a lot. You may not pay attention to it, like I have not. But you know, customer, customer, they're just like, I don't know. They probably go by your credit card name or whatever. But what's important is the invoice. The invoice is gonna be the one that's in order here, and it'll show the exact amount that this one customer paid during the transaction for the day. Let's just say that this is all within a day. This is the first transaction, second, third, fourth, fifth transaction of the day, and this is what they paid. All right. Perhaps they paid for a service, a business to business service. That's why the cost is so high, and everyone's paying in like cash and stuff. So that's what an invoice table looks like. Oh, they're joining it too. Crazy. So 2000 would go with 2000, ABC, XY, TRY, TRY. You can examine the software. Yay. Components of DBMS. Alright, guys. So a DBMS software includes these components as discussed in the following sections. We're going to be going over database engine, data definition, data manipulation, uh, application generation, and data administration. All right, database engine. Boom. So, a database engine, the heart of the DBMS software, is responsible for data storage, manipulation, and retrieval. It converts logical requests from users into their equivalence reports by interacting with other components of the DBMS, usually the data manipulation component. For example, say a marketing manager wants to see a list of the top 3 salespeople in the Southeast region. It's a logical request. The database engine interacts with a data manipulation component to find where the 3 names are stored and display them on a screen or print it out um, if you want to see the physical equivalent of that. And because more than one logical view of data is possible, the database engine can retrieve and return data to users in many different ways. Data definition. So let's go back. So if you're doing really well, there is a database out there, for all of those managers that truly do care about you. They can definitely see it. They can see the database. They could see who's doing well, who's not doing well. They can see all of that and reward accordingly. And if you think you were a top performer, you could tell them to pull it up through a database engine. Data definitions. The data definition component is used to create and maintain the data dictionary and define structures of files in a database. Any changes to a database's structure, such as adding a field, deleting a field, changing a field size, and changing the data type stored in a field, are made with this component. Don't ask me what that means because I do not know. Data manipulation. The data manipulation component is used to add, delete, modify, and retrieve records from a database. Typically, a query language is used for this component. Many query language are available, but structured query language SQL, um, for some of you that might say SQL, and um, query by example QBE are two of the most widely used. Structured query language is a standard fourth generation query language used by many DBMS packages such as Oracle Database 12, Microsoft SQL Server. Boom. I guess this is like extra. SQL consists of several keywords that specify actions to take. The basic format of an SQL query is as follows. Select field from table or file where conditions. So let's make it a little bit easier. This is a prompt. Let's have the prompt. So something that is not immutable, something that's not changeable. All right. This right here is changeable. So let's just say select field. The field would probably be, make it easy, let's just say it's like a name or something. Table or file conditions. So you create your own conditions. After the select keyword, you list the fields you want to retrieve. You list whatever you want to retrieve in the field list. After from you list the tables or files where you want to retrieve the data, right? And where your conditions, the criteria for retrieving the data. All of this comes together because the databases that you're going to be seeing are very hefty, very big. So it's nice to have something like SQL that is able to search up that data, the data. The following example retrieves the name, social security number, title, gender, and salary from employee payrolls for all the employees with a job title of an engineer. Select name, all right, SSN, title, gender, salary. So all these fields that this person has selected was name, SSN, title. So I'm going to color that blue for you. Um, and then I'm going to color that so it could make a little bit more sense for those who are not understanding, um, or those who would like a better explanation of what's going on. Okay, so the select field, they selected name, serious social security number, title, gender, and salary to display. All right, so this would display everybody if we didn't have these others right now. All right, we're not going on. We're just this selected the name, social security title, gender, and salary. So if there was anything else after that, maybe like job title or comments or something like that, that would be filtered out and it would only show this. Right, which is still a lot of data. So it's going to ask where from the table or file they chose employee payroll. All right, and then where they're gonna say employee.ssn equals payroll.ssn and title equals engineer. So this is just uh, fancy language that you will be using in some of these database management systems softwares. So let's move on because we're not really there yet. A database engine, the heart is responsible, blah, blah, blah. This query means that data in the name, SSN, I think we just went through this, right? Yeah. With query by example, QBE, you could request data from a database by constructing a statement made up in query forms with current graphical database, you simply click on select query forms instead of having keywords as you do in SQL. So you select query forms. You cannot add and not operators to the QBE form. Fine-tune the query. And means that all conditions must be met. For example, major equals MIS and GPA is, what is that? Greater than 3.8. Means a student must be majoring in MIS and have a GPA higher than 3.8 to be retrieved, right? Or means only one of the conditions must be met. Conditions meaning MIS or GPA, right? For example, major equals MIS or GPA greater than 3.8. These two would be together. Oh, means that the student has a higher GPA than 3.8. The student can be majoring in another field. So, alternative is students major in MIS, the student can have a GPA of 3.8 or lower. Not searches the record that do not meet the conditions. For example, major not accountant retrieves all the students except accounting majors. Application generation. Woo! In application generation component, a database is used to design elements of an application such as data entry, screens, interactive menus, and interfaces with other programming language. These applications, for example, might be used to create a form or generate a report. If you are designing an order entry application for users, you could use the application generation component to create a menu system that makes the application easier to use. Typically, IT professionals and database administrators use this component. I just read through that and I did not understand a single thing. Isn't that crazy? Data administration. Data administration component, also used by the IT professionals and database administrators, is useful for tasks such as backup and recovery, security, and change management. In addition to this component is used to determine who has permissions to perform certain functions, often summarized as CRUD, which is create, read, update, and delete. So some people have the function able to create, like when you perhaps joined your workplace, your job, and they gave you a um, customer, not customer, a employee ID. You weren't the one that created the uh, what is it, employee ID. It was most likely someone in sysadmin or any IT professional, maybe a manager. Don't know. Whoever that job role falls on, they are the one that created the um, employee ID for you. All you could do is read and maybe update some information, right? And you also do not have if you're an employee, you probably don't have the permission to delete your employee ID. You might be able to um, update and delete maybe smaller things, maybe like your gender, right? Maybe you mistyped your gender and you want to update it, right? But generally, they will do all of that for you after you written it all down in before applying to the position. In large organizations, database design and management is handled by the database administrator. Okay, there you go. Although the complex database and task is sometimes handled by an entire department, the DBA's responsibility includes the following: designing and setting up a database, establishing security measures to determine users' access rights. Access, so they're making sure where you get access and what you can do. Developing recovery procedures in case data is lost or corrupted. So a lot of these companies have backup recovery, backup data, backup uh, everything. Just maybe some server caught on fire with everybody's information. The information is actually on cloud nowadays, and if you're not on cloud, you're on some legacy stuff. It could possibly be because you don't want your information leaked outside of the company, which happens quite a bit. But you know, uh, these data breaches are very common because you are trusting a lot of people within an organization with this data. It's bound to get leaked somehow, right? It's just a extra layer of security if you don't want to switch over to um, cloud. Not saying that cloud isn't um, like cloud has security. It's just that it's just an extra layer of security. Like, say you work in the government, you don't really want your government files to be on the cloud, right? Maybe um, another country could be able to do a little data breach and get into the government files. That's why you would want to have it in legacy systems or traditional databases or on physical servers, whatnot. All right. If you guys are learning, hit that subscribe button and hit the like. If not, take out a notebook, pen, pencil, and start learning. This is free, valuable information right here. Possibly. The graph database move relational databases one step forward. A graph database is a database that uses graph structures for query operations, nodes, edges, and properties to represent and store data. Boom. A typical relational database stores entities and their properties in tables, whereas graph database also stores relation between entities. It focuses on connections between entities and navigates and manages connected data. This enables database operations across different but related entities. In healthcare industries in particular, this has proven to be very helpful, as many doctors belong to multiple healthcare providers. Diseases have may have multiple symptoms, and there may be multiple relationships among organizations such as insurance companies, hospitals, and different employers. Healthcare providers such as CureSpan Health Group, Good Start Genetics, Share Practice, and Janssen Pharmaceuticals use Graph Database for patient management, drug research, genomics, clinical trials, and marketing. And there you go. They share your data. There's a lot of like signatures and signings of things nowadays because of so. Give me a second. Let me. Online dating websites also use graph databases, and they believe that this technology has increased the accuracy of the recommendations provided. Don't believe in online dating; they are all for your money, okay? And then the people on there are out for your money too. They're not out there. to um, date. I mean, if you're able to, make a match with somebody on there, good for you. Perhaps it's the future, but you might find a better chance on something else that you both enjoy, like a hobby. Gaming could be for one, you know, uh, rather than a dating website or a dating application. Be careful if you're on there, is all I'm saying. There are OF people in there that are out there to um, prey on your, let's say, your needs. I don't know, prey on your, I forgot the word, so we're just gonna move on from it. The graph, the use of the graph database is beneficial because people in an extended social network, friends of friends, and even friends of friends of friends, are much more likely to go on a date together than two complete strangers are. Crazy. Social media companies such as LinkedIn, Facebook, and Twitter are also prime users of graph databases. In addition, companies such as Walmart, eBay, Lufthansa, and Deutsche Telekom use this technology. Problems are such that fraud detection and asset management are also good candidates for graph databases because they provide the opportunity to better understand the connections between data and deriving the meaning from linking among data items. Man, that was a lot. Significant insights can be drawn from existing data simply by reframing the problem and looking at it in a new way in a graph format. Major providers of the graph databases include Neo Technology, GraphBase, blah 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 blah. Okay, what is the difference between relational database and graph database? Dude, I already forgot. And which businesses, if you guys know the answers, comment down below. Which, and then have the other one answered as well. Which businesses benefit the most from graph databases? Well, that's easy. Wait, businesses. Never mind, it's not easy. Forgot. Also, Prime users. There you go. LinkedIn, Facebook, and Twitter. Yay! There's your answer for number 2. Recent trends in database design and use. Have it read for a second. I guess it didn't decide to read. Recent trends in database design and use include data-driven websites, natural language processing (NLP), distributed database, and object-oriented databases. In addition to these trends, advances in artificial intelligence and natural language processing will have an impact on database design and use, such as improving user interfaces. Module 13 covers natural language processing and the other trends discussed in the following sections. Data-driven websites. With the popularity of e-commerce applications, data-driven websites are used more widely to provide dynamic content. A data-driven website acts as an interface to a database. retrieving data for users, allowing users to enter data in the database. Without this feature, website designers must edit the HTML code every time a website's data contents change. This type of site is called a static website. A data-driven website, on the other hand, changes automatically because it retrieves content from external dynamic data sources such as MySQL, Microsoft SQL Server, Microsoft Access, Oracle, IBM, DB2, and other databases. The data-driven website improves access to information so users' experience are more interactive, and it reduces the support and overhead needed to maintain static websites. A well-designed data-driven website is easier to maintain because most content changes require no change to the HTML code. Instead, changes are made to the data source, and the website adjusts automatically to reflect these changes. With data-driven websites, users can get more current information from a variety of data sources. Data-driven websites are useful to following applications. Among others, e-commerce sites that need frequent updates, need news sites that need regular updating of content, forums and discussion groups, subscription services, and such as newsletters. Great. Distributed databases. The database type discussed so far. You know what? Can I have this thing read for me? Is that possible?
Distributed databases. The database types discussed so far use a central database for all users of an information system. However, in some situations, a distributed database management system, DDBMS, in which data is stored on multiple servers placed throughout an organization, is preferable. Here are some of the reasons an organization would choose a distributed database. The design better reflects the organization's structure. For example, an organization with several branch offices might find a distributed database more suitable because it allows faster local queries and can reduce network traffic. Local storage of data decreases response time but increases communication costs. Distributing data among multiple sites minimizes the effects of computer failures. If one database server goes down, it does not affect the entire organization. The number of users of an information system is not limited by one computer's capacity or processing power. Several small integrated systems might cost less than one large server. Accessing one central database server could increase communication costs for remote users. Storing some data at remote sites can help reduce these costs. Distributed processing, which includes database design, is used more widely now and is often more responsive to users' needs than centralized processing. Most important, a distributed database is not limited by the data's physical location. There are three approaches to setting up a DDBMS, although these approaches can be combined. Fragmentation. The fragmentation approach addresses how tables are divided among multiple locations. Horizontal fragmentation breaks a table into rows, storing all fields, columns, in different locations. Vertical fragmentation stores a subset of columns in different locations. Mixed fragmentation, which combines vertical and horizontal fragmentation, stores only site-specific data in each location. If data from other sites is needed, the DDBMS retrieves it. Replication. With the replication approach, each site stores a copy of data in the organization's database. Although this method can increase costs, it also increases availability of data, and each site's copy can be used as a backup for other sites. Allocation. The allocation approach combines fragmentation and replication. Generally, each site stores the data it uses most often. This method improves response time for local users, those in the same location as the database storage facilities. Security issues are more challenging in a distributed database because it has multiple access points from both inside and outside the organization. Security policies, scope of user access, and user privileges must be clearly defined, and authorized users must be identified. Distributed database designers should also keep in mind that distributed processing is not suitable for every situation, such as a company that has all its departments in one location. Object-oriented databases. The relational model.
Let's skip this one since we went over this already. Look at that, we're ahead of ourselves, guys. Isn't that great? Okay, so data warehouse is a collection of data from a variety of sources used to support decision making, application, and generate business intelligence. Okay. Data warehouses store multidimensional data, so they are sometimes called hypercubes. Ooh, isn't that a crazy name for just a warehouse full of really noisy servers? Typically, data in a data warehouse is described as the following. Actually, let me pull it up too. Data warehouse. Boom, let's get this image into your guys' minds. Oh, crazy tech stuff, but it doesn't actually look like this. It looks really, really, really neat. Well, I guess I didn't work in such a neat place like this. I don't even know if it exists. If this one looks like it's fake, but this is what a data warehouse look like. All right, that's why they call it hypercubes, I guess. Um, okay, so it's subject oriented, focused on specific areas such as home improvement industry or university, whereas data in the database is transaction function oriented. Integrated comes from a variety of sources where data in databases usually does not. Time variant, categorized based on time, such as a historical information, whereas data in a database only keeps recent activity in memory. Type of data captures aggregate data, whereas data in database captures raw transaction data. Purpose used for analytical purposes, whereas data in database is used for capturing and managing transactions. Okay. I'm not going to read all that, but we will go over this right here. Database warehouse configurations, okay? So, all of these are in the warehouse. The external data sources, databases, transaction files, enterprise resource planning systems, ERPs, some of you guys might know, and then customer relationship management systems, the CRMs, extraction, transformation, and loading into raw data, summary data, metadata. Oops, let me get that out of the way. All right, the input. Data comes from a variety of sources, including external data sources, databases, transaction files, enterprise resource planning (ERP), ERP systems, and customer relationship management systems. ERP systems collect, integrate, and process. Let me write that down, or let me highlight. ERP systems collect, integrate, and process data that can be used by all function areas in an organization. Cool. CRM, on the other hand, systems collect and process customer data to provide information for improving customer service. All right, so this one collects, integrate, and process data that could be used by all functional areas in the organization, and then CRMs are collect and process customer data to provide information for improving customer service. Module, let's see if I can open this one up. Whoa, okay, it's just, that is, this is a whole chapter by itself, guys, so we will go, we will go into that when the time comes, alright? However, for now, let's go back to the database portion of this segment. Together, these data sources provide input data warehouse needs to perform analyses, and generate reports. ETL, extraction, transformation, and loading, refers to the processes used in data warehouses. Oh, is it? That's not even it. Refers to the in the data. It includes extracting data from outside sources, transforming it to fit into operational needs, and loading it into the end target database or data warehouse. Extraction. Man, I am peeling so much everywhere. What is going on? Weather's got me crazy. The extraction process can also parse data, divide it into pieces to make sure it meets the data warehouse structural needs. For example, parsing can be used to separate the street number, street name, city, the state in the address if you want to find out how many customers live in a particular region of a city. Transformation processing is done to make sure that data meets the data warehouse needs. Its tasks include selecting only certain columns and rows to load, translating coded values, such as replacing yes with 1 and no with 2, performing select project and join operations on data, sorting and filtering data, aggregating and summarizing data before loading in the data warehouse. Loading is the process of transferring data into the data warehouse depending on the organization needs and storage. Collected information is organized in a data warehouse as raw data, summary data, or metadata. Raw data is information in its original form. Summary data gives users subtotals of various categories which can be useful. For example, sales data for a company's southern region can be added and represented by one summary number. However, maintaining both raw data, disaggregated data, and summary data, aggregated data, is good idea for decision making purposes, as you learned in module 1. Metadata is information about data, its content, quality, condition, origin, and other characteristics. Metadata tells users how, when, and by whom data was collected, and how data has been formatted and converted into its present form. For example, metadata in a financial database could be used to generate a report for shareholders explaining how revenue, expenses, and profits from sales transactions are calculated and stored in the data warehouse. So, a little bit of extra research if you want to know about metadata. Output. Yay, we're finally to the output. The data warehouse supports different types of analysis, generates reports, and for decision making. The database discussed so far support online transaction processing (OLTP) to generate reports such as the following: which product generated the highest sales last month? Which region generated the lowest sales last month? Which salesperson increased sales by more than 30% last quarter? Data warehouses, however, use online analytical processing and data mining analysis to generate reports. These are discussed in the following sections. When Netflix recommends movies to you based on your viewing history, it's using information generated by data mining tools. Did you know? Rubik's Cube. Online analytical processing. Online analytical processing, unlike OLTP, is used to quickly answer multi-dimensional analytical queries, thereby generating business intelligence. It uses multiple sources of information and provides multidimensional analysis such as viewing data based on time, product, and location. For example, if you want to find out product X performed in the Northwest region during the previous quarter, you could use OLAP. Sometimes this analysis is called slicing and dicing data. In other words, OLAP breaks into an entire body of data down into smaller parts or examines it from different viewpoints so that the user can determine it better. The hypercube in Exhibit 3.7 can be sliced into different directions. Boom, 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 boom. It's been sliced up. You can think of this hypercube as a multi-dimensional spreadsheet, which with each side representing a dimension such as a region, geography. There you go. Um, The advantage of a hypercube is that it enables fast manipulations and calculations that in the hypercube in Exhibit 3.7. Each smaller cube in dimension represents subdivision of data. Data in one of these smaller cubes could pertain to the sales of a canned good in the Northeast region in 2022. Each smaller cube can be subdivided further. For example, 2022 can be divided into financial quarters. So 2022 can be divided into financial quarters somewhere. I don't know. For Q1, Q2, and Q3 and Q4. Yeah. So boom, 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 boom. The number of cubes can be determined by the granularity, specificity of each dimension. Oh my goodness. Data mining analysis is used to discover pattern and relationships. For example, data mining. You might be hearing this a lot. Data mining, right? Let's finally understand what they mean by data mining. Uh, For example, data mining tools can be used to examine point of sale data to generate reports on customers' purchase histories. Based on the information, a company could better target marketing promotions to certain customers. Similarly, a company could mine demographic data from comment or warranty cards and use it to develop product that appeal to certain customer groups such as teenagers or women over the age of 30. And if you guys notice that I am trying to do the same thing for a client of mine, however, my client is not particularly listening to me. So after I finish up what I have to do with my client, I will cut ties. And if he wants my services further, then I'm definitely charging him the next time around. Netflix. Okay. Let's see here. Where were we? Similarly, a company could mine demographic data, warranty, we just read that, such as teenagers or women over the age of 30. When Netflix recommends movies to you based on viewing history, it is using information generated by data mining tools. Ooh, crazy, right? It's going into your psychology. Netflix awarded a $1 million prize to a team that devised the best algorithm for substantially improving the accuracy of its movie recommendations. Um, Crazy. That $1 million prize is nothing into comparison of how great the algorithm is going to be just to make you stay on there and keep watching. American Express conducts the same type of analysis to suggest products and services to cardholders based on their monthly expenditures. Patterns discovered by using data mining tools. The following are typical questions you can answer by using data mining tools. Which customers are likely to respond to a new product? Which customers are likely to a new ad campaign? So this is just like, I'm telling you, these things are like really in your mind. So kind of scary. Target marketing stuff. Eh. What products should be recommended to customers based on their past buying patterns? Vendors of data mining software include SAP, Business Objects, SAP, SAS, and IBM Cognos Analytics, Cognos, and Informatica, or Informatica. Yeah, these are all data mining software. All right, highlighting the application of data mining in the airline industry. All right, let's read about the airline industry and how they pertain to data mining. There's probably some oh yeah, social and ethical issues here. In the airline industry, data mining could improve customer service and at the same time increase revenue. Wow. Soon, an airline crew will know if, say, the customer in seat 19A is a vegetarian or allergic to certain foods. The crew will also know which passenger lost their bags on a previous flight. Airline marketing is becoming more sophisticated based on passengers' online browsing history and wealth of information available through social media to sell products and services to their passengers. Some airlines now combine the passenger flight information, such as name, frequent flyer number, age, income, and address, with social media information, such as the number of likes on the passenger's Facebook page. All this information can be accessible to flight attendants equipped with tablets and smartphones in the cabin. Data mining could improve targeted in flight sales and showing passenger destination income and social media interest. For example, show tickets, helicopter tours, and tickets for boxing matches could be sold to passengers en route to Las Vegas. However, airlines must make every effort to protect the privacy of their passengers. There must be a balance between providing excellent customer service and protecting the passengers' personal information. So, what do you guys think? Do you guys think that would you want better customer service, or do you guys want your personal information to be protected? And there is no perfect balance between the two. Everyone is different, right? That's why you have the option to opt out of a lot of these um, nosy companies, right? But at the same time, um, if you're going on vacation, you're trying to have fun, you don't know what to do. Uh, the data mining tools and all these companies out there that have studied you could recommend some good stuff for you. Great customer service. It's tricky, very tricky. Your data is valuable, and you should protect your data at all costs, or at least educate yourself to the potential harms of releasing data. The, so, questions and discussions. How could data mining improve customer service and at the same time increase revenue in the airline industry? Talk amongst yourselves in the comments down below. What are some challenges in using data mining for this particular application? Text mining analysis. Text mining data analysis is the process of analyzing a vast amount of textual information to capture key concepts, trends, and hidden relationships. Dang. Businesses collect and process three types of data: structured, such as name, addresses, sales totals, and phone numbers; unstructured, which is social media data, product reviews, videos, audio files; and then semi-structured, a mixture of structured and unstructured, such as email, electronic interchange, and device IDs. It is estimated that 80% of data throughout the history is in unstructured format. Text mining analysis is of this massive amount of data. It could generate valuable information, which could result in improved decision-making processes and better business outcome. Text mining analysis could reduce operational costs, uncover previously unknown relationships, and reveal insights into the future trends. There are numerous applications of text mining and analysis, including the following popular option: customer service, text mining analysis, and online reviews and social media profiles, likes and dislikes, call centers transcripts, and online service enables business to respond to urgent issues in real time and increase customer satisfaction. Risk management. Text mining analysis enables business to monitor shifts in sentiment in the marketplace and extract information from analysis for market report and papers in a timely manner, which can reduce decision making. Risks. Healthcare. Text mining analysis could be provide an automated method for extracting valuable information from vast amounts of medical literature. This could result in a better healthcare system with reduced costs. Spam filtering. Email spam is a global problem. Oh man, I didn't know it was a global problem. Yeah, I guess I could see why they're always sending emails and stuff. Text mining analysis can be used to provide a filtering method to exclude spam from inboxes, which improves overall experience and system performance and minimize the risk of phishing. Yes, guys, phishing still happens and it still works because there are still older people in the field that would click on these phishing emails. But, some of these hackers are getting a lot smarter nowadays. Popular text mining include tools like Monkey Learn, IBM Watson, Google Cloud NLP, and Amazon Comprehend. Oh, I didn't know Amazon was in on it. Or I didn't know about it. Decision-making reports. The data house can generate all this information as well as reports used for decision-making. What would it do? You could cross-reference segments and organization operations comparison purposes. For example, compare personal data with the data with the finance department, even if they have been stored in a different database with different formats. Generate complex queries and report faster and easier than when using databases. Generate reports efficiently using data in a variety of sources in different formats and stored in different locations throughout an organization. Find patterns and trends that cannot be found in databases and analyze large amounts of historical data quickly. Assist management in make a decision. Manage very high for information. Manage a high demand for information for many of the users' needs decision making styles. Great. Data marts, yay, is usually smaller version of data warehouse, usually used by a single department function. Woo! Data marts are focus on business functions and specific user group in an organization, such as data marts for marketing department. Despite being smaller, data marts can usually perform the same types of analysis as data warehouse. Data marts have the following advantages over data warehouses. Access to the data is often faster because of their smaller size. Response time for users is improved. They are easier to create because they are smaller and often less complex. They are less expensive. Users are targeted better because data marts is designed for specific department or division. Identifying their requirements and the function they need is easier. A data warehouse is designed for an entire organization's use. Data marts, however, usually have limited scope than data warehouses, and consolidating information from different departments and functional areas such as sales and production is more difficult. Data lakes gather and store data in its original format in a central location. The collected data can be structured as well as unstructured. Data lakes are not intended to replace data warehouses, rather, the two alternatives are complementary. Data lakes and data warehouses are complementary. Compared with the data warehouse, data lakes are more suitable for big data analytics and machine learning application discussed in. Hold on. Looks kind of weird. Yeah, I kind of sit like that sometimes. Let me get that down from the camera. Highlights key differences between the two. Okay, so key factors here: types of data, application of collected data, key users, accessibility, update procedures, storage space, costs. So types of data for data lake is raw, and then data in data warehouses is processed. All right, applications of collected data, not yet determined and currently in use. Key users, data scientists for data lakes and any decision maker that needs it in the data warehouse. So on and so on. Because data lakes are more flexible in gathering and storing all types of data, and organizations must exercise tight access control, otherwise the data may turn into a data swamp and of unusable raw data. A growing number of industries and businesses are using data lakes as preferred alternative to data warehouses. The healthcare industry is a good example because the nature of the data it collects, because its processes in structured and unstructured data, such as physician notes, clinical data, and X-rays. The education and transportation industry are also beneficiaries of data lakes. Amazon is a prime user of data lakes. This platform enables Amazon to break down and data silos, perform advanced data analytics, increase data access, and accelerate machine learning. There are several platforms for successful implementation of data lakes. The most popular include Amazon Web Services S3, Microsoft Azure Data Lake, and Google Cloud Storage. Dang, we're only halfway there. Shit, man. Business analytics. Uses data statistics methods to gain insight into the data and provide decision makers with information they can act on. Okay, guys, let's speed it up a little bit, huh? You guys are more than welcome to pause at any time and have a look over it. Just scroll through. It's taking a little bit longer than I thought it would, so I'll just what I'll stop where I feel like it would be important to know. Where two applications, mobile analytics and Airbnb. Doing big data entry. Big data era. Companies and MasterCard involved big data for years, processing billions of transactions in a typical holiday weekend. However, there has been an explosion in data growth throughout the business world in recent years. And in fact, this massive volume doubles every 1.2 years. Blue Cross and Blue Shield will provide healthcare insurance to nearly 33% of American successful use of predictive analytics. BCBS has established a database that contains more than 100 million medical claims to control. That's a lot. Increasing medical costs, BCBS uses predictive analytics to identify the risk factors that lead to several chronic diseases. It also predictive analytics to identify individuals who are at heightened risk of getting such diseases. And then they don't give you insurance. Isn't that great? The goal is to be able to use data to get doctors to provide better, more targeted care for high-risk patients, reducing their need for expensive long-term treatments. Oh, that's nice of them to do. Match.com, an online dating service, is also a successful user of predictive analytics. Isn't that crazy? That's crazy. Having predictive analytics, I would actually like to see what that looks like. The result of the exponential. Oh, I'd like to see the process of all of this going down. The data is so voluminous that conventional computing methods are not able to efficiently process and manage it. There are 5 dimensions to big data. They are known as the 5 V's. So remember that, guys. Volume, variety, velocity, veracity, and value. Volume is the sheer transaction measured at petabytes or exabytes. Here are four examples of big data volume. All the packages shipped through the U.S. Postal Service the week before Christmas, the sales on Walmart stores on Black Friday, all the items purchased on Amazon on Cyber Monday. These are all examples of a big data volume. Variety. A combination of structured data, customers' product ratings from one and Tide, and unstructured call center conversation of customer complaints about the service product. Most data available on the social networks is unstructured business combined data collected from the internet with various handheld and mobile devices, with location related data and multimedia data, machine to machine communication data, which is velocity, the speed in which the data has to be gathered and processed. And as an example, imagine a billboard that could display a particular ad as soon as a particular customer drives by it. That would be crazy. The billboard would recognize the driver's face by comparing with human faces in huge database and integrated with the driver's social media data and find out the driver's favorite are based on. Well, you see, something like this would probably be different. It wouldn't be like that. The future that I am imagine that we're gonna go down is having a big VR set on our heads. Hopefully, they could shrink it down to like some type of glasses, and um, everywhere you go, you're most likely going to see ads just up there in the sky, and you can't even see skies anywhere until you disconnect yourself from the that VR AR augmented reality world. But that's definitely where I mean I would actually enjoy something like that. Being able to have glasses and go through I don't know videos and stuff with my glasses instead of like looking down at my phone. I would rather just have it right there, and then whatever I'm performing my functions or whatever, I could just have a video playing right there while I'm just working. That'd be nice. I mean, I have it might be TikTok or whatever making my attention span smaller and smaller, but it is what it is. But that's the direction that I see um, that we're going, and not having billboards change as drivers drive past it. I don't see that at all. Anyways, off of that tangent, veracity. The trustworthiness and accuracy of the data, for example, social media posts, abbreviation typos, and colloquial speech make this dimension important. Important. However, in most cases, volume makes up for the lack of quality or accuracy. Value. The value of the decision making process. If there is no value, then the entire process, data collection, and analysis would be a waste of resources and miss the windows of opportunities. For these reasons, value is the most important V of big data. Remember that, guys. Value, volume, velocity, veracity, and value. I forgot one more, variety. Well, who benefits from big data? Many industries could benefit from big data analytics and gain competitive advantage in the following areas: retail, financial services, advertising, public relations, government, manufacturing, media, blah blah blah, energy, healthcare. Yeah, they could all benefit from big data. How? For retail, customer relationship management, retailing retail offerings to customer needs. Say that you're in the market for shoes, right? They will send you newsletters of shoes instead of trying to sell you hats. You weren't in the market for hats. You're in the market for shoes, right? Risk analysis, fraud detection, attracting new customers, and advertising, targeted advertising, more effective messaging, government, national security, airport security, blah blah blah, blah, manufacturing, product research. Yeah. Tools and technologies of big data: Tableau, SAS, big data analytics, SAP, click view. These are all tools and technologies of big data. Big data privacy risk, of course. Here it is, the data risks of, or the privacy risks we were all here for, right? Big data analytics is able to provide key decision makers an unprecedented support and great potential for gaining a competitive advantage. However, this powerful tool could reveal and expose certain information that puts some people's privacy at risk. Shocker. It also may create some legal and ethical concerns. The following list describes the risks associated with this technology. Key executives should make every effort to guard against these risks and eliminate or at least minimize their impact. It will always happen, guys. All they can do is try to eliminate it or minimize it. All right. Discrimination. Big data analytics may reveal information that gives decision makers, such as a banker, a reason to approve or to decline an individual's loan application. Privacy breaches and embarrassments. Big analytics may reveal that a retail customer, for example, is pregnant by sending promotional materials related to pregnancy. Yikes. This person may not have made her pregnancy public yet, creating embarrassment and privacy issue. That has happened before. Um, let's see if I could pull it up. Big data and and target pregnancy. There we go. Oh, shit, I can't get on there. Here we go. I don't want to put target under fire, but here's the thing. By Drive Research, uh, Target used data analytics to predict pregnancies. Well, what does this story have to do with you? Well, hold on. I know that all of my viewers are not pregnant per se, but this does affect you in some way. Okay? Big data and predictive analytics can frighteningly tell an accurate story. So, what has happened here? Target used a modeling data analytics to identify women as being pregnant before those same women would tell her closest friends and family members. In this case, the brand used data analytics to predict pregnancies to determine purchasing habits of those who were expecting. So they were Target was targeting pregnant people with targeted ads like maybe um, clothes, diapers, stuff like that. You know, the normal things that you would buy for kids. But that's not what made this like, oh, they're then using data to help us buy stuff. No, this isn't the thing. Um, so I think, let's see, the where is it? How Target figured out a teen girl was pregnant before her father did. Okay, so they were sending all these things and um, like these targeted newsletters and stuff to her. And the thing is, she didn't know that she was pregnant, right? I think this is how the story went. She didn't know that she was pregnant, and it was through Target because of what Target found out. Like Target crazy predictive analytics things that they had going on. So the person was a frequent shopper. That lady or girl, that teen was a frequent shopper of Target, and she bought. Her spending habits changed. Like she didn't buy the regular food that she usually buys. She started buying something outside of the norm. You know, something that wasn't like NPC for her. She wasn't like living her life as per usual, and it was through the predictive analytics. It started sending newsletters about like diapers and stuff to her, and she was just confused, like, why is it sending me um, diapers and all this baby stuff? Why is it sending to that teenage girl? It turns out that she was getting to be pregnant, and Target knew it before she did, and it caused a lot of drama. That's how I think the story goes. And if it's not how the story goes, then sorry, but the point is that predictive analytics is a bit scary. So I could skip all this. Alright, throw on the chat thing for a second, the voice. And
Integration of IoT with big data analytics. We talk about the Internet of Things, IoT, in detail in Module 4. IoT is the assortment of sensor-based devices that are used all over the world for diverse applications. They collect structured and unstructured data 24/7 from the factory floor, from smart homes, and from everything in between. According to IDC, 90 ZB of data will be created on IoT devices by 2025. IoT big data analytics can be a powerful tool for a variety of applications. They can do the following: examine various situations from the industrial field, the medical field, and others. Reveal trends that can be used for forecasting and planning. Find unseen patterns that can be used for marketing opportunities. Find hidden correlations that can be used for marketing opportunities and other managerial decision making. Reveal new information that can be used for competitive advantage. Different industries will benefit in different ways from this integration. The following is a sample list of industries.
we're not gonna go we're not gonna go too deep into this. That interesting. Yeah, that's why. Database marketing. See if there's anything here that you might need to know. Analytics, how this means the different techniques for monitor customer behavior across numbers of channels. You might need to know that would include websites, social media, customer communication, using different techniques of communicate effectively with customers, increase loyalty, customer. In the internet of business, use number of tools to communicate, including email, websites, portals, social media, internet, blah 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 blah. Goes on. Recency, frequency, and monetary analysis (RFM). This model generates an estimate that tells this is how valuable. Yeah, not that interesting. What is Tableau? Tableau you're going to be using a lot. All right, these are the two very popular business intelligence and visualization platforms, software that you will be using. Uh, so, Tableau is a data visualization tool and for generating business intelligence. It is used to analyze data for generating trends using graphs, charts. Tableau's users can do the following. Tableau. Explore, find quick data patterns, reproduce, further analyze data patterns, and create multiple charts, stuff like that. Basically, this is what Tableau looks like, guys. This is Tableau right here. It makes data and stuff very, very nice. You know, it's a user-friendly visualization of business intelligence. Tableau is a powerful platform to perform visual analytics that help design visualization that uses minimal analytics background can easily be understand and use. It can utilize data from various sources, including data files, with such formats as Excel and PDF and relational database, and as well as big data sources. It is extensively used in both private and public sectors, including academic researchers, businesses, and many government agencies. The Tableau product suite includes Tableau Server, Tableau Desktop, Tableau Reader, Tableau Online, and Tableau Public. Some of these unique features of Tableau include the following: superb visualization. Yeah, it's probably like the biggest selling point of Tableau is it looks very nice, you know. For those business people that can't stand the basic cut and dry things. They need colors and stuff to stimulate their senses. Users can switch between different visualizations to zero in on a particular data point in drilling up and down. In-depth insights, users can explore a visualization of view of same data from different angles. Users can perform what-if analysis and blah blah blah. User-friendly interface for sure. There's no reason why anybody in the world don't know how to use Tableau. Access through drag and drop techniques, no program is needed to use this platform. It works with the disparate data sources. Users cannot connect and analyze various sources, including data warehouses, spreadsheets, big data, can add data sets. What is Power BI? It's the other one, which is from Microsoft. Let's see what that looks like. I have not seen Power BI before. I probably should if I'm getting into it. Let's see some images of Power BI. So it looks exactly like Tableau, except it's a little bit more professional looking rather than user friendly in the other one. Wow, cool. Okay. Same thing, seamless integration with other data existing applications, the ability to create, advantages of Power BI, the ability to personalize dashboards for different users and diverse information needs, deliver actionable information with high speed, accuracy, and security. Major components is a Windows desktop application called BI Desktop, and also an online SaaS product of this, which is very, very nice. If you guys haven't gotten into SaaS, you guys probably have used SaaS but don't even know about it. But it's a very nice thing to have. You can go into any computer and log into your account and then access it from anywhere. So you can work from anywhere essentially. Power BI mobile apps for Windows, iOS, and Android devices. Okay, cool. I would definitely use Power BI over Tableau then. Let's see. Oracle Corporation. Yeah, Oracle stuff. Don't really care. You probably should. Here is the review. Pause it if you guys would like. Here are the key terms. There you go. Alright. And these are the reviews and discussions to ask yourself to, let's just say, understand database further. Make sure that you guys understand what databases are. Alright? And I think that is that. And I don't know if you guys want to do projects. However, if you guys want to go all the way and do that and also quiz yourself, be my guest. Alright. That will be all for this stream, guys. Okay? We will be talking about marketing in the next stream, and then stay tuned for a um, video. The video is going to be very nice. It's going to be a little bit more higher production value, and so, you know, there's a bit of entertainment there. And also, it will um, define a couple of our game plans, what we're what what we're deciding for the channel, what the channel is going to do. And dang, this thing took 2 hours, man, just to study one one section or one chapter. Dang, that's so long. Anyways, it's worth it because I don't know the because. It's just worth it because you know more, right? Anyways, have a good time, guys. Until next time. Peace out.